So today we're going to be talking about changing the subject of a formula. In order to do that, let's go back to our trapezoid. So we know, or maybe we don't, but we should, because we just did it, know that to find the area of a trapezoid, you take 1/2 times a plus b, so you find the average of the two bases, the top and the bottom, and you multiply it by the height. So what does it mean to change the subject of a formula? Well, what if I wanted to change my formula so that b was the subject of the formula? So let's talk about what I would do to make b the subject of the formula. And as we work on it, then maybe you can think about why this is something that I would want to do. So the first thing I'm going to go ahead and do is multiply both sides by 2. So then as you can see, what's going to happen is this 2 will cancel out with this 1/2. So now I have 2a equals, in parentheses, a plus b times h. Next thing I'm going to want to do, so the idea is making b the subject of the formula, I'm going to divide both sides by h. Let's make that a better looking h. Alrighty, there we go. So now I have 2a over h equals a plus b. Notice that those parentheses are now gone because there isn't anything being multiplied to it, so now that's just a plus b, which means now if I want to get b by itself, the last thing I need to do is subtract a from both sides. So then my final answer, or changing the subject of the formula, yields me b equals 2a over h minus a. So the question then, it gets back to, really, why would I want to do this? Well, let's just say I needed to find the value of b. Now, it's true I could just plug in the values and then multiply things around and simplify in order to get the answer once I have b, but it's also just as easy, I think, to set up my formula in terms of b. So if I'm trying to find the value of b when a equals 7, h equals 10, and my area equals 75, well, now I'm just plugging in values that I already have, and my solution is going to be that subject that I'm looking for. So it's going to be 2 times 75 divided by the height, which is 10, minus 7. So then my answer is going to be b equals 150 divided by 10 minus 7. Order of operations, 150 divided by 10 is 15. So b equals 15 minus 7. Or, as we squeeze it in over here in the corner, b equals 8. So changing the subject of a formula allows me to move values around, move unknowns, so that my answer doesn't require any shifting around later. Let's take a look at another example. So the first thing I'm going to do here is just focus on expressing u as the subject of the formula. So the idea is to get u by itself. First thing I think I'm going to do is subtract the 1/2 at squared over to the left side of the equation. So now I have s equals, s minus 1/2 at squared equals ut. Then I'm going to go ahead and divide this by t, divide that by t, and I'm going to get u equals s minus 1/2 at squared over t. Now the danger here is that you're going to look at the t squared and t and you're going to want to think, oh, I can just cancel those out. But I can't, because this is s minus 1/2 at squared. This is a combined term. I cannot simplify in that way, just like we did in prior lessons. You can see now how it relates. Now here we go, we're going to get a little trickier. I want to make t the subject of the formula here. So you'll notice t is in the denominator. What we really need to do is get rid of that fraction. So the first thing I'm going to do is multiply both sides by t minus 2x, which means I'm going to multiply the left side over here by t minus 2x. So now I have y times t minus 2x equals 4t plus 3x. All right, and you might be thinking to yourself, Mr. Chavez, you're not getting any closer to making t the subject of the formula. Well, here's what we're going to do. We're going to go ahead and expand that y using the distributive property because I want to get rid of the parentheses. So that's going to get me yt minus 2xy equals 4t plus 3x. So once I get rid of those parentheses, then some magic can happen, really. Because the next thing I'm going to do is switch values around so that my t's are on the left side and my other values are on the right side. So what I'm going to do is subtract 4t from this side, which moves it over here to the left. And then I'm going to add, actually let me move that over here just a little bit. And then what I'm going to do to this 2xy is cancel it out from the left, which means I'm moving it to the right. So now what happens as we rewrite things, I have yt minus 4t equals 3x plus 2xy. So now this is one step closer to getting making t the subject of the formula, because now I have yt minus 4t. I can factor out a t, and I'm left with y minus 4. So I've gone from 2 t's to 1. This step is a crucial step, just as much as getting the t out of the denominator was over here. So now I have t times, in parentheses, y minus 4 equals 3x plus 2xy. So now the last thing I'm going to do is divide both sides by the parentheses of y minus 4, so that my final answer then becomes, oh, I'm running out of space. Let's go up here. We're going to erase you so that I'm left with t equals 3x plus 2xy over y minus 4. And if you want to, you can go ahead and take that one step further and factor out the x so that you're left with x times, in parentheses, 3 plus 2y. But you don't have to. Just to show you what that would look like, it would be t times x in parentheses 3 plus 2y over y minus 4. They mean the exact same thing. So really the idea here is you're changing the subject of the formula so that you can input values later for x and y in order to solve for t. So I'm going to leave you with one more problem. This is a challenge problem. Rewrite the equation s equals pi r times the square root of h squared plus r squared such that h is the subject of the formula. So you're doing this one by yourself. Do it on a separate sheet of paper because it's totally worth some extra credit. If you figure out how to get h by itself the right way, I will totally give you some extra credit. How much? I don't know. We'll just have to find out.